Alright, we're going to start this video still with long division. We are going to get to synthetic. I just want to do one more long division problem. So we're taking this polynomial and dividing it by x plus 5. So let's put the dividend underneath the house. X plus 5 is on the outside. So one more time again, we're thinking, x goes into 3x to the squared. What do I need to multiply this by to get 3x squared? We definitely need a 3, and we need an x. So now I'm going to take 3x and multiply it by both these things on the outside here. So 3x times x is 3x squared. 3x times 5 is 15x. I like to put that in parentheses because what am I going to do? Subtract that away. So 3x squared minus 3x squared is nothing. 3x minus 15x is negative 12x. Bring down the minus 60. Alright, we're going to repeat the whole process again. X now is going into negative 12x. So x times what to give me a negative 12x? Well, we need a negative 12. What do we do with the negative 12? We multiply it by both these things on the outside. Negative 12 times x is negative 12x. Negative 12 times 5 is negative 60. Put that in parentheses. Make our line. We're going to be subtracting these. So negative 12 minus a negative 12 is nothing. Negative 60 minus a negative 60, again, is 0. Okay, now we're going to be talking about synthetic division here. So synthetic division is a shortcut method of using long division. You can only use it when you are being divided by x plus or minus some number. So if you happen to have a number in front of this x, you couldn't use synthetic division. You are basically using the coefficients here. So what I'd like to do is take a look at all the coefficients of my dividend. We have 2, 4, an imaginary 1, and then a negative 3. I am going to take those 4 numbers, write them down, 2, leave a little space, 4, imaginary 1, and then negative 3. I'm going to make a thing like this. And on the outside is what I am dividing by. Now I need to get a number here. So whatever you're dividing by, which is x minus 1, make it equal to 0 and solve it for x. So I am actually dividing by 1 here. If it was x plus 1, I would solve it and subtract 1 on both sides, and that would be negative 1, but it's a 1 here. Alright, when you're doing synthetic division, after you set up all your coefficients, and then what you're dividing by on the outside, you always are going to bring down the first number. So I am going to bring down whatever first number is here, which is the 2. I'm going to write it there below the line. So the process is to take this number now, that's first, and multiply it by what's out here. So 2 times 1 is 2. That answer you're putting under the next number that you have lined up, which was the 4. Now you're not going to do what you did for long division, subtract. You're going to just add whatever's there. So you just have to watch your signs. So I brought down the 2. 2 times 1 is 2. Now I'm adding these 2 up. 4 plus 2 is 6. I'm going to repeat the process till I get to the very end. Now I'm going to do 6 times 1 on the outside, which is 6. I'm going to put it in the next spot. And 1 plus 6 is 7. Again, take what the result is here, 7. 7 times 1 is 7. Again, I'm going to add this up. Negative 3 plus 7 is 4. So this over here is my remainder. That means that x minus 1 doesn't perfectly divide into this big polynomial. So let's see how I need to now write the answer as a polynomial, my result. How would I write this answer? Here we started with x cubed and we divided it by an x. So that means I'm going to take away one of those powers there, always one less, and this is going to become 2x squared. Because I started with the third, it's going to go down by 1. 2x squared plus, what would come next after x squared? X. So this would be plus 6x. What comes after x? Just your regular number, plus 7. And then my remainder here is 4 over that divisor, x minus 1. We usually add it, put a little plus there. So this is my answer with synthetic division for this problem. Alright, so I'm going to move it up. Okay, this one here, using synthetic division, I'm going to divide this big polynomial by x plus 3. So remember, we are taking a look at all the coefficients that we have here. Does anybody notice one that's missing? I notice that x to the third is missing here. So I need to consider and put that as a placeholder of 0. And that's something that a lot of students forget to do. Alright, so let us write the numbers down. There's the imaginary 1. Then we have to have 0. Negative 10 is next. Negative 2. Positive 4. I'm gonna make my, kind of like my box here. I need to now, here are my 5 numbers, put my number that I'm using over here. So x plus 3 equals 0. What number am I putting on the outside? If I solve it, negative 3. So negative 3 is going out here. Alright, so what was the process again? Always bringing down that first number, which is 1. Taking that number that's here on the bottom, multiplying it by what's out here is negative 3. 1 times negative 3 is negative 3. Add those up together. 0 plus negative 3 is negative 3. Repeat the process again. Negative 3 now times negative 3 out here is positive 9. Add these together, I get negative 1. Again, same thing. Negative 1 times negative 3 is 3. Add these together, I get 1. 1 times negative 3 is negative 3. Add these together, I get 1. And who remembers what this is at the end? This is my remainder. So that means x plus 3 is not a factor of this big polynomial because it doesn't divide evenly. Alright, how would I write my answer here? So remember, we go back to what we started with, which was x to the 4th. Our answer is always 1 less, so that means this one's going to be 1x to the 3rd. Now we keep going down. Minus 3x squared minus 1x plus 1 plus, and here's my remainder, 1 over what? That divisor, x plus 3. So this is my answer for the last problem.